All right, so section 18 is just a review of what we were doing yesterday, which is implicit differentiation. So part A, I think you guys probably all got. So it says find the derivative of the full lemma of Descartes, which is x cubed plus y cubed equals 3xy. So if you remember the full lemma of Descartes, it looks like, there's a picture of it like that. Okay, just remember that picture. All right, so as we take the derivative, we end up getting, anytime we take the derivative of x, it's just like it would be, right? So it's going to be 3x squared. But when we take the derivative of a y, we tack on a dy over dx. Okay, meaning the derivative of y in terms of x. All right, so when we have 3x times y, just make sure that you do the product rule with that. Okay, so you're thinking as 3x and then times the y. So I'm going to break it up into 3x, and then the derivative of y is going to be dy over dx. And then plus the derivative of 3x is 3, and then y normal. Okay, did everybody get that? All right, so now you want to get all of the dy over dx terms together. So I want to get this and this on the same side of the equation. And then this one and this one can be on the other side of the equation. So it doesn't matter what side you get them on. So let's say I have 3x dy over dx minus 3y squared dy over dx. And then I have 3x squared minus 3y. Okay? So when we do that, that allows us to pull out a dy over dx. So we'd have 3x minus 3y squared. So your final answer then is going to be dy over dx, and you're going to take the 3x squared, I guess not final answer all the way, and divide by the 3x minus 3y squared. So what do you notice that they all have in common? A 3. So basically you pull a 3 to the front for each of them, and then the 3's cancel. So did you guys all catch that on yours? So your final answer is dy over dx equals x squared minus y over x minus y squared. All right. Now some of you might have had a different answer. Okay, if you had y minus x squared on top and then y squared minus x on the bottom, it's totally fine. Okay, it's basically like multiplying by a -1 over a -1. It's not changing your fraction at all. So it really just depends on which side you took the dy over dx terms to, on which version of those answers you have. Okay, but they're exactly the same. All right, so B says find the equation of the tangent line at 1.5, 1.5. So when we plug in 1.5, 1.5, we have 1.5 squared minus a 1.5 all over 1.5 minus a 1.5 squared. And you can waste a lot of time, like on the AP test, trying to figure out what this is, especially if it's non-calculator. You're like, okay, 2.25 minus 1.5 all over 1.5 minus 2.25, right? It takes a lot of time. Do you guys know what it's going to be? -1, right? Because it's the same thing over itself, it's just one has been like as a negative that you can pull out. Okay, so it ends up being -1. So don't waste a lot of time doing that when you can use tricks. All right, so your equation of your tangent line is going to be y minus a 1.5 equals -1 times x minus a 1.5. Okay, so that's part B. So are we good so far? A and B good? All right, part C is kind of the weird one. All right, so part C says, at what point or points in the first quadrant is the tangent line horizontal? So it's important when we use the word point. Whenever you see point or points, you need an x coordinate and a y coordinate. All right, so it says, where is the tangent line horizontal? So our tangent line was dy over dx equals x squared minus y over x minus y squared. So if it's going to be horizontal, we want that numerator to equal 0. So we want dy over dx to equal 0. A lot of times you get a point just for writing that. So we want x squared minus y to equal 0, the numerator to equal 0. So when we do that, we actually have two variables, x and y. So we can't actually solve for x and y unless we have another equation that has x and y. Okay, so the thing that we're going to do is we're going to try to find another equation that has x and y. We're going to use the original, right? So the original is basically saying for any curve, if you have a tangent line, that line is intersecting the curve at that point. So if I'm finding an intersection point, I'm just doing substitution or elimination. All right, so my original equation was x cubed plus y cubed equals 3xy. So we're going to replace all of our y's with x squared. So we get x cubed plus x to the 6th equals 3x cubed. And we subtract over. So x to the 6th minus 2x cubed equals 0. So we can pull out and x cubed. So we get x equals 0, and when we set x cubed minus 2 equals 0, we get x equals the cube root of 2. So again, we wanted the point. So those are the x coordinates. We need to find the y coordinates. So we go back to any equation that has x and y in it. Well, isn't this the easiest one? X squared equals y. So we're going to go back there. We're going to find y by just squaring x. So we're going to have 0, 0. And if I take the cube root of 2 and I square it, you could write it as 2 to the 2/3. That's one way of writing it. Or you could say, oh, I have the cube root of 2 times the cube root of 2, so it's still going to be the cube root of something, the cube root of 4. Those are equivalent. They're exactly the same. So I'm going to say cube root of 4. I'm just going to kind of keep it consistent with the roots. So those are your 2 points. Did anybody get both of those? Yeah, that's kind of a hard one. All right, so number 2, so it says find dy over dx at the specified point, and then write the equation of the tangent line at that point. So find the derivative of y with respect to x. In other words, find y prime. So we're going to do 2x plus 2y times dy over dx equals 0. We're going to subtract the 2x over, and we're going to divide by the 2y. So we get negative x over y. Did you guys all get that for the derivative? Good. All right, then we're finding the slope at a specified point. So at 2 comma root 5. So it's going to be negative 2 over root 5, which we can leave like that. You don't have to rationalize. So when we plug it in, we're going to have y minus y1 equals m times x minus x1. That's our equation of the tangent line. Yes?
For part C, why don't you also take the negative for the square root?
When you take the cube root, it's all just the positive. But if it was a square root or a fourth root, then you would do plus or minus. Because like the cube root of negative 8 is just negative 2. Like you don't say plus or minus 2. All right, so this next one. So I have sine of x plus cosine of y equals 2 at pi over 2 comma 0. This is a very tough question. The answer should be x equals pi over 2. Okay, and I'm sure that a lot of you guys didn't get it. Okay, so let's talk about y. So we have sine of x, its derivative is going to be cosine of x. Cosine of y, its derivative is negative sine of y dy over dx. And then the derivative of 2 is 0. So we're going to subtract our cosine of x over. And we're going to divide by the negative sine of y. So we get cosine of x over sine of y. So if we're trying to find the slope at pi over 2 comma 0, you guys probably plugged it in. And you're like, oh, okay, I get cosine of pi over 2, that's 0. And then sine of pi over 2, that's 0. So I get 0 over 0. Well, what does that mean? Right, that's undefined, right? So we have a slope that is undefined. What does that mean about the line? Yeah, Spencer? Oh, sine of 0. I was skipping ahead. Sine of 0, thank you. Is 0. So we got 0 over 0, which is undefined. So what does a line look like when its slope is undefined? Yeah, it's a vertical line, right? So that means our tangent line is a vertical line. We have a vertical tangent. Okay, so a vertical tangent, if you think about what lines look like if I had this line right here through 2, that's the line x equals 2. Every single point on that line has a 2. 2 comma 0, 2 comma 1, 2 comma 3. So what is our equation going to be? X equals, look at the point we have. Pi over 2. That's the answer that I was looking for. So it's kind of tricky. Now going back to that last one, if you check well, not the last one, part C, if you check 0, 0 in the slope, you actually get that 0, 0 makes it undefined, right? So it's like, wait, is it a horizontal tangent or is it really a vertical tangent? And it's a really weird situation. It's not a function. But here's what's happening on that graph. So if you think about what that folium of Descartes looks like, which is probably why he was interested in this problem, it looks like that. Okay, it has a vertical tangent and a horizontal tangent at 0. Do you guys see it? So it's flat here, like as I approach from the left, it's flattening out to a slope of 0. But it's also vertical. Does that make sense? So it's both vertical and horizontal at 0, 0. So if I'd asked for the vertical tangent, 0, 0 would also be a vertical tangent. Isn't that weird? I don't know. Blows your mind. All right, maybe not so much because they're like, I don't care. I think it's an interesting function. Okay, so the next one. So if I'm finding dy over dx, I'm going to take the derivative. So I'm going to have 5 y to the 4th dy over dx plus product rule, so x squared times 3y squared dy over dx plus 2x times y cubed equals 0 plus, again, product rule, so x to the 4th dy over dx plus, 4x cubed y. Okay, did you guys all get that? So if you get all of your dy over dx's on one side, and you pull out the common factor, dy over dx, you have 5y to the 4th plus 3x squared y squared minus x to the 4th equals, and you get everything else on the other side, 4x cubed y minus 2xy cubed. So your answer should be dy over dx equals 4x cubed y minus 2xy cubed all over 5y to the 4th plus 3x squared y squared minus x to the 4th. Okay, did you guys get to that one? Okay. Okay, and I do want to talk about one more of these. So you could do part B. I can't remember what the answer is. I can write it down for you guys if you want. Let me get it real quick. But then if you do part 4, or number 4 is asking for the second derivative. So that's kind of a weird notation. We've talked about that notation before. So yeah, when you see d2y over dx squared, that's just saying the second derivative. That's all it is, y double prime. Okay, so this answer, if you check your answer for part B, you should get cosine x, cosine y, minus cosine of x, all over sine x, sine y, minus sine of y, like that. Oh, I do have more time. I was thinking class was over. It's not over, is it? Okay. I can do that one if you get confused. And remember, you could also multiply by -1 on the top and bottom. So you might have cosine of x minus cosine x, cosine y, sine of y minus sine of x, sine of y. All right, so then this last one. So it's asking for the second derivative. So we're going to go ahead and take this equation, and we're going to do the first derivative. So I'm going to have 0 minus x times dy over dx minus 1 times y equals 1 minus dy over dx. Do you guys see how I took the derivative there? All right, get everything on one side that has dy over dx, so I get 1 dy over dx minus x dy over dx equals 1 plus y. So this was like a 1 dy over dx. So then when I pull a dy over dx out, my placeholder is still there. 1 minus x equals 1 plus y. So dy over dx equals 1 plus y over 1 minus x. Okay, did you guys get that for the first derivative? Okay, good. So now the second derivative, you just take that and you take the second derivative. So our second derivative is going to be, we write it as d2y over dx squared. All that, the d2 means like second derivative, meaning like y double prime. The dx squared is kind of a nod to the units. If we've talked about the second derivative before, with real life problems, we've talked about acceleration. Do you guys remember? Where it was like meters per second squared. It's indicating that that unit on the bottom is the squared unit now. So that's why we write it that way. So anyway, so I'm going to have low d high. So the derivative of high is derivative of 1 plus y is just dy over dx. Minus high d low is just going to be -1 all over the square of what's below. So the nice thing about this is when we plug in dy over dx, remember, it's 1 plus y over 1 minus x. Do you see what happens? Yeah, the 1 minus x and the 1 minus x cancels. That's nice when that happens. All right, and then the next ones, we have negative and negative, so we end up getting plus 1 plus y all over 1 minus x squared. So we get 1 plus y plus another 1 plus y. So we get 2y plus 1, or no, wait, 2y plus 2 all over 1 minus x squared. That is the second derivative. Did anybody get that one? No? Okay. All right, so that's a quick review of our implicit differentiation. Do you guys all remember how to do that? So remember, you guys do have homework for tonight. You have that worksheet that I gave you, but that's not due until after fall break. So how many of you guys